Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 6.2, example 4, page 252. Okay, so what we're doing, it's what we did yesterday. We are having to graph a function, but instead of them giving us the function, they're giving us a word problem and we're having to figure out what the function is. So the number of pounds P of carbon dioxide produced by a car is 20 times the number of gallons G of gasoline used by a car. Write and graph a function that describes the relationship between G and P. Okay, so I need to pull out the important information. The number of pounds P of carbon dioxide produced by a car. So we have pounds of carbon dioxide produced. Pounds of carbon dioxide produced by a car is 20 times the number of gallons G of gas. 20 times the number of gallons of gas. So I've just taken all of this information and pulled out just the important stuff, the stuff that I need. Pounds of carbon dioxide produced is 20 times the number of gallons of gas used. Okay, now I can work on solving this. Whenever I have a word problem that I need to turn into a number sentence, I always start with my word is. Is a good starting place because is means equals. Is means equals. So now I need to figure out what all of this means before my equals sign. Then I can figure out what all of this is after my equals sign. So pounds of carbon dioxide produced. Pounds of carbon dioxide produced. The word problem said that this is going to be represented with P. So the pounds of carbon dioxide produced is P. Okay. Now we need to figure out what all of this means after the equal sign. 20 times. 20 times. Well, that's easy. 20 times. Okay. So here's my 20 times. The number of gallons of gas used. So number of gallons is going to be represented by G. Number of gallons. So we have taken this word sentence and turned it into a number sentence. And take a look at the color coding. Pink, yellow, blue, green. Pink, yellow, blue, green. My number sentence matches my word sentence. Okay? And when you are turning a word sentence into a number sentence, always start with the word is, because is means equals. So now we need to graph this. You guys know how to do that. X. Here's my function. Okay, this looks all fine and dandy, except I have X and Y's, and in here there's P's and G's. Okay, do you guys remember back in chapter 4, we were using linear equation format, y equals mx. This is in the same format as y equals mx. Do you guys see that connection? Now this is telling me that my y is actually P, which is pounds. And my x is G, which is gallons. So if it helps, you can color code that. My pounds are my y, and my x is gallons. So it's color coded. So now let's think about this logically. Can we put negative gallons of gas in a car? You can't put negative gallons in a car. So we are not going to use negative numbers. We're going to start with 0. We can put 0 gas in a car. We can put 1 gallon of gas in a car. We can put 2 gallons of gas in a car. We cannot put negative gallons. So now at this point, it's just substitution. I'm putting in input, I'm putting in 0 gallons of gas. So I'm going to substitute 0 for G. I'm putting in 0 gallons of gas. When I put in 0 gallons, I get out 0 pounds of carbon dioxide. And that kind of makes sense. 0 going in, 0 coming out. That kind of makes sense. 0 gallons going in, 0 pounds of carbon dioxide coming out. Now let's try 1. So my pounds are equal to 20 times, I've got 1 gallon going into the car. 1 gallon going in. So if I put 1 gallon in, I get 20 pounds of carbon dioxide out. Input, output. I'm putting in 1 gallon. I'm getting out 20 pounds. Put in 1, get out 20. Now we're going to put in 2 gallons. So input, we are going to put in 2 gallons of gas. When we put in 2 gallons, we get out, output, 40 pounds of carbon dioxide. So input, output. Now we have 3 ordered pairs that we can work with. Since I don't have any negatives, I am only working in the first quadrant. I only need the first quadrant. This is my x-axis, and we said x was gallons. So color code that. And this is my y-axis. And
we can't see.
Y is pounds. What do you mean you can't see?
Can you move the notebook just a little bit up, please?
There we go. So there we go. So sorry about that. Y is pounds. So looking at my scale, I'm going to use a scale of 1 for gallons. And looking at pounds, I should probably use a scale of 10. Now I'm going to plot these. If I put in 0 gallons, I get out 0 pounds. if I put in 1 gallon, I get out 20 pounds. If I put in 2 gallons, I get out 40 pounds. And ta-da! We have just graphed this function. So this graph is telling me and showing me however many gallons I put in, this is how many pounds of carbon dioxide come out. So that's what we're doing today. How about if we do one more example? Okay, in the chat, give me a thumbs up if you're ready to move on. Give me a yes if you're ready to move on, or a no if you need to wait a minute. Okay, let's go ahead and do another example. Okay, right here. The distance M in miles traveled by a car is 35 times the number of gallons G of gasoline used by the car. So the distance M in miles traveled by a car. So miles traveled by a car is 35 times the number of gallons of gas used. The number of gallons of gas used. So I just tried to take all of these words and pull out just the important information. Miles traveled by a car is 35 times the number of gallons of gas used by that car. So now I need to take this word sentence and turn it into a number sentence. And when I do that, the first thing I always look for is my is, because is means equals. It breaks this problem up into manageable parts. Now I need to figure out this part before the equal sign. Miles traveled by a car. Okay. M. Miles traveled by a car is M. Got it. 35 times. Well, that's easy. 35 times. 35 times the number of gallons of gas. The number of gallons of gas, G. The number of gallons of gas, G. So we have now taken this word sentence and turned it into a number sentence. And now we need to graph this function. So we're going to create our table. X, our function, Y, and our ordered pair. Now, this is all fine and dandy, but I have X and Y's and M's and G's. Which is X and which is Y? Well, Y equals MX right here. So my Y is M, miles. And you can color code that if it helps. My X is G, gallons. And you can color that. Might help. So now let's think about this. Can we put in negative gallons of gas? Is it possible to put into a car negative gallons of gas? It doesn't make sense. So we're going to start with 0 gallons of gas, 1 gallon of gas, and 2 gallons of gas, because we can't put in negative gallons of gas. So we're only dealing with the positives. So now we're going to substitute. The miles is equal to 35 times 0 gallons of gas. We're putting 0 gallons in. This is our input. We're putting 0 gallons in. So if we put 0 gallons in, we get 0 miles out. And that kind of makes sense. If you put 0 gas in, you're getting 0 miles out. That kind of makes sense. So let's do 1 gallon. What happens when we have 1 gallon of gas? So we are going to put in 1 gallon of gas. If we put 1 gallon of gas in, we get 35 miles out. So 1 gallon of gas in, 35 miles out. Now let's put in 2 gallons of gas. So we're putting in input 2 gallons of gas. When we put in 2 gallons of gas, we get 70 miles out. So we're inputting 2 and the output is 70. So now we have our 3 ordered pairs. And since I don't have any negatives, I only need to deal with the first quadrant. So since this is my x-axis and x equals gallons, there's my x-axis, x equals gallons. This is my y-axis and y equals miles. Okay, so here's my y, and y equals miles. So let's look at my scale. For gallons, I think I'm going to use a scale of 1. And for miles, I think I'm going to use a scale of 10. So if I input 0 gallons, I get out 0 miles. If I put in 1 gallon, I get out 35 miles. If I put in 2 gallons, I get out 70 miles. Boom. Done. We have now graphed this function. And what this graph tells me is for 1 gallon, I can go 35 miles. For 2 gallons, I can go 70 miles. For 3 gallons, I can go 105 miles. This is the graph for this function. So that's what we're doing today. We have to turn the word sentence into a number sentence, and then we need to graph it.